In this video, we're going to talk about what pi is. The circumference of a circle is always a little bit more than 3 times as large as the diameter. So let's say we had a circle over here, and here we see the same circle over here. We could take a ruler and just measure how long the diameter is. I made that line over here pretty thick just so you could see it. But let's say we took a ruler and measured the diameter of the circle, and then we used the ruler again to measure the circumference of the circle. If you remember from the last video, there's a little trick that we could do to do that. We could just take some string and wrap it around the circle, and then cut it like that, and then we could just stretch out that piece of string to see how long the circumference is. So we could use that little trick to measure the circumference of the circle and then stretch the string out on the ruler. All right, and then we could just compare how many times longer the circumference is than the diameter. Actually, I think longer is a better word than what I had before, so I switched the word large over here to long. But anyway, let's take a look at this example. So it looks like the diameter of this circle is about 2¼ well, let's pretend that this is a ruler with actual inches on here. Then the diameter of this circle seems to be about 2¼ inches. And it looks like the circumference of the circle, which I stretched out into this arrow over here, seems to be about 7¼ inches. So let's go ahead and just take a calculator and divide 7¼ which is 7.25, by 2¼ which is 2.25. And we get 3.2 repeating there. So here the digit of 2 seems to repeat over and over again. Now I want you to keep 2 things in mind about what we just did here. Number 1, this circle that I drew, and then I drew it again over here, is not a perfect circle. And number 2, I didn't really do a very good job of measuring that. Okay, this little ruler picture that I have over here is, I don't know exactly how accurate it is. And also I was just eyeballing it a little bit at the end. I don't know if that looked like it was about 2¼ but I was probably a little bit off there. So number 1, it's not a perfect circle that we're using. And number 2, I didn't do such a great job of measuring the diameter and the circumference with great accuracy. Okay, so with that in mind, I want to tell you that the closer we do get to a perfect circle, and the more accurately we measure the circumference and diameter, the closer we will get to a number 3.1415, and it keeps going actually. So again, the circle that I had was not perfect, and I didn't measure it perfectly either. But the closer we get to actually having a perfect circle, and the more accurately we measure the circumference and diameter of that circle, the closer we will get to this number over here when we divide the circumference by the diameter. Okay, and you could ask a couple of interesting questions here. One, is it even possible, or do perfect circles actually exist in nature? And 2, if they did exist, would we be able to measure them with perfect accuracy? So we could have an interesting discussion about that. But if we did, ideally, if we did have the closer we get to a perfect circle and the more accurately we measure it, the closer we will get to this number when we divide the length of the circumference of that circle by the length of the diameter. Now, I did not read this sentence yet. This is true regardless of the size of the circle. So let me just get some blank space down here. Okay, it does not matter how big the circle is. So for example, I could have, and just pretend that I'm drawing these circles imagine that these are perfect circles here. Let's say I have a big circle over here and I have a smaller circle over here. If I were to take a string and make the string go around the circumference of the circle and then just stretch that string out, let's say it would look something like this. All right, and if I were to then measure the diameter of that circle, it's about this long. Okay, so this is the circumference of the circle over here, and this is the diameter of the circle over here. The circumference of the circle is a little bit more than 3 times longer than the diameter of the circle. I don't know if I drew that perfectly, but it's true of this circle, and it would be true of this smaller circle as well. If we were to take the circumference of this smaller circle and sort of stretch it out, then maybe we would get something like that. And then the length of the diameter of this circle, let's try to, okay, I hope I drew this about, well, this should be the same size as this, right? That should be the length of the diameter. Okay, again, and I might not be drawing this perfectly, but the length of the circumference should be a little bit more than 3 times as long as the length of the diameter. Okay, that's true no matter how big or small the circle is. It could be as big as Jupiter. It could be as small as, I don't know, the tip of this marker over here. All right, if it's a perfect circle, then when you take and Jupiter is not a perfect circle, and neither is this, but if it's a perfect circle, you take the length of the circumference, you divide it by the length of the diameter, you will get 3.141592. Okay, it's a number which goes on and on forever, but it's still just a little bit more than 3. Okay, even though it's got a lot of digits after the decimal point, it still is just a little bit bigger than 3. And again, that's true regardless of how big the circle is. Now let's take a look at this number over here. I already said it does go on forever, but something else about it is that it never repeats itself. Okay, so this number goes on and on forever without repeating. So I don't know if you remember what I did before. Let's do that again. This was when I was actually not very accurate, and I got this number. So I was pretty close, but not exactly this. This number over here, 3.2 repeating, I could write this, if I have a repeating decimal, then I could write that as 3.2 with a bar over it, and that just means that the 2 repeats forever. Okay, but this number over here, this number goes on and on forever without repeating. Okay, so a bar will not work. For example, you might be thinking, well, couldn't we just write something like this, 3.14, and put the bar over the 14, and that means all this? No, this is not the same as this. This means 3.141414, etc., like that. This is not the same as this number that we have over here. Well, what if we did some more digits? What if we did 3.14159 and put a bar over all that? Would that be the same? No, that would just be 3.141591415914159, etc., forever. But this never repeats. It doesn't repeat starting at the beginning, and it doesn't repeat at any point further along. Okay, so what do I mean by that? Let's say we had something like, 3.14159265265, and the 265 kept repeating over and over and over again. Well, then we would be able to write 3.1415925 and put the bar over the 265. that would be okay. But this number over here, at no point is it going to start repeating itself. Not from the beginning and not anywhere. Even if you go a million decimal places in, it will never start repeating itself. So we're never going to be able to write this number using a bar as if it repeated itself like what I just wrote over here. So what can we do? We can't just go on writing forever every time this thing comes up. We can't just keep writing and writing and writing and writing and writing forever, right? So what people do is they said, okay, you know what? Instead of this number, we're just going to replace it with this symbol over here. And this symbol is it's a letter in the Greek alphabet. It's called pi. And people just use this letter, which is pi from the Greek alphabet, to represent this number so that they just don't have to keep writing digits forever. So instead of writing the circumference of a circle divided by the diameter of the circle is equal to 3.14 blah, 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 they will just write that the circumference of a circle divided by the diameter is equal to pi. That's how it would be written. But remember that pi simply stands for this number over here. So pi is simply a number which is a little bit bigger than 3, which is what we get when we take the circumference of a circle and divide it by the diameter. Okay, so that's it, and have a great day.